Welcome, everyone. We've got a packed evening ahead of us, so strap in. It's going to take a little bit of time. But first of all, a warm welcome to the Bradfield Centre. This is the 7th edition of this competition, which is crazy. I don't know where the time has gone. It's been great to see how the competition has grown over those 7 years. We've tried to continue to innovate with the support that we offer, the teams that are coming through the competition. So we've expanded the range of prizes on offer. We've incorporated the Hellings Prize. We've added the Angel Prize, which is all about rewarding and recognising the commercial progression of previous finalists from year to year. And tonight you're going to see some of our previous alumni, as well as the people pitching for this year's prizes, which is fabulous. We've also added a series of entrepreneurial workshops, which are delivered by Cambridge-based founders. So our teams get to learn directly from practitioners, which I think is really important. And this year we're filming it for the first time, which you might have noticed. So there's an incredibly bright light shining in my face. Yeah, everyone will be on film. I hope that's okay. And that'll play a big role of helping to grow the exposure of the ideas and the teams tonight, which is obviously a big reason for applying to these kinds of competitions. There's a whole range of people to thank for making the competition possible. Time probably doesn't allow me to cover everyone, but I'll have an attempt. First of all, Maximilian. Obviously, without you, Max, we couldn't do this, so my appreciation and thanks. From Trinity College, there's a very long list of names here, but Richard, Grillo, James, Bill, Sean, Jamie, Roman, so many people. Mantle, Mark, Ella, Bo, Kay, Joe, guys here as well. Great team from Mantle. The catering team led by Monica, whose food you'll be enjoying around 7:30 tonight. Of course, our wonderful judging panel. Hopefully you've seen the names in your handouts. Take an opportunity to network with our judges tonight. Of course, the founders and subject matter experts that have delivered the workshops that I mentioned, so Christina, Rachel, Lucy, Alexander, John and Steve, and our university partners that help promote the competition across the university. I'm really proud of the fact that we get such numbers and quality and diversity of applications in this competition, and that's really down to our partners helping us to spread the message. So that includes IE Cambridge, Impulse, Judge Business School, King's eLabs, iTeams, and we've had applications, I think, this year from 18 different departments and 19 different colleges. So it just gives you a flavour of the breadth of the reach that we have. So as I said, there's a lot of content to get through. I know you'll be impressed. Max and I have spent the last week or so working with the teams to polish their pitches tonight, and it's an amazing lineup. Good luck to everyone. And without further ado, let me introduce David Secher from Trinity College.
Thank you, James. Let me add my welcome on behalf of Trinity College to the Trinity Bradfield Prize. The prize is named after, as you probably know, the great John Bradfield, the senior bursar of Trinity College, who in 1970 conceived and then implemented the Cambridge Science Park where we are now. The first in the UK, and it's one of the Science Park has been described recently by Innovate Cambridge as one of the moments in the development of the Cambridge ecosystem. So an incredibly important event in 1970. So I'm David Secher. I'm the interim senior bursar at Trinity College, standing in for Richard Turnill, who's on a well-deserved holiday. And I've been involved for many years now in technology transfer and entrepreneurship in Cambridge, including more than 20 years ago as the architect of the university's first intellectual property policy, one of the most generous to inventors in the UK and an important foundation of the development of the Cambridge ecosystem. So now fast forward to 2026, and as you heard, this is the 7th Trinity Bradfield Prize competition, one of the key entrepreneurship support programs in Cambridge. Trinity College now supports entrepreneurship in many ways. The Bradfield Centre, where we are, the Trinity Plus, and the Trinity Venture Academy but the Trinity Bradfield Prize is the jewel in the crown. Originally created by Sir Greg Winter, the prize aims to encourage and assist young scientists, engineers and entrepreneurs in and around the University of Cambridge to start companies capable of translating their ideas, inventions and discoveries into products. We've had more than 500 teams apply to the competition in those 7 years, and a number of previous winners have gone on to raise significant venture capital as they grew their ideas into fully fledged companies. Examples include Sparkcell, Loci, and Boltspit, and many others have been successful. The full list of previous winners can be seen on the Trinity Bradfield Prize website. I'm really excited to hear this year's candidates pitch, and so without further ado, I'll hand you over to Max G. Thank you.
Welcome, everyone, to the 2025-26 edition of the Trinity Bradfield Prize. It's always great to see such a full room of enthusiastic Cambridge ecosystem people and beyond come to our event. Just so you're aware, the room may be getting even more crowded in a moment as we have another group of students from our very new Venture Academy program upstairs who may be joining in for a little bit later as well. Right, just so you're aware, you can see, just to make out the fire exit on both sides of the room in case of emergency. Please do go there. There's also bathrooms just outside of this room in case you need. Feel free, obviously, to make use of those. I shall keep things short. And this year, we're bringing you an extra large amount of pitches, and we're trying to obviously utilize the time as effectively as possible. You will see selected 9 finalists pitch here tonight. And they span the Cambridge ecosystem all the way from life sciences to engineering to new materials and to photonics and quantum as well as sustainability. So it is really a vast range representing the enormous amount of activity here in the ecosystem. In addition to that, we will also bring you essentially some reports of companies that have been finalists in previous years, so you can see where they are essentially headed to in their journey. We bring you 2 alumni pitches, and we also have 3 pitches at the end who are going for the Angel Prize, which makes actually the Trinity Bradfield Prize quite unique in the sense that we are awarding a prize also for the best progress of a venture over the last year. So not just how they do in the moment, but we are very much caring that they are contributing in a sustainable way to the things. Now, just very briefly, to highlight our excellent panel of judges sat in front of you, as the Senior Bursar of Trinity just mentioned, we have Sir Greg Winter with us, who is not only the founder of this prize competition and a Nobel laureate in chemistry, but also obviously brought this particular format to life to drive more scientific discovery into commercial reality here in Cambridge. Joined, we have Carrie Baldwin here, founding partner of IQ Capital. We have John Yeoman here, co-founder of Cambridge Angels. We have Robert here, who's co-chair of Cambridge Angels. And we have Christine, who is the head of seed funds or ventures now at Cambridge Enterprise. So these are people who in their daily lives see many pitches in a vastly wide area of scientific expertise and business acumen. And we are really glad to have them here to, support our new generation of founders on their early journey. Right. To give you an overview, here are the finalists that we have selected for this year's pitch. And as James said, to be honest, the quality of the founders and their pitches is definitely something that's improving every year, which is, I think, a testament to the great amount of support that is given around the ecosystem here. And so we have been giving them an extra kind of round of help in delivering the pitch to the audience here tonight. And so, well, without further ado, I shall just bring up the first pitch that will be kicked off by Catherine from Cambridge Droplet Microfactories.
Well, hello everyone. I am Dr. Catherine Fan, a co-founder of Cambridge Droplet Microfactories. Firstly, I'd like to thank the judges for selecting us as one of the finalists for the Trinity Bradfield Prize and giving us the opportunity today to show you all how to express the inexpressible protein. At Cambridge Droplet Microfactories, we've developed a platform to provide higher yields and purity for the production of proteins that cannot be expressed or expressed inefficiently using industry standards. But why proteins? Well, proteins are used in a plethora of applications, ranging from life-saving medicines, such as antibodies, to contributing to the development of new biofuels and biomaterials. Driven by this diverse relevance, the recombinant protein market is experiencing robust growth, currently valued at £3.6 billion with a strong compound annual growth rate. And a standard way to produce these proteins is by expressing them inside bacteria, as they are fast-growing, have low cost, and are easily scalable. A bottleneck here, though, is that some of these proteins, such as DNA-binding ones, are cytotoxic to bacteria. This reduces growth rates and causes cell death, killing our production line. Our microdroplets can reduce this toxicity to the cell by sequestering the target protein inside our droplets, preventing the protein from causing any harm to essential cellular components. Essentially, we've created specialized storage containers that allow for a greater diversity of proteins to be expressed in bacteria, reducing the overall production costs of high-value proteins. The development of our microdroplets stems from 2 years of postdoctoral research here at the University of Cambridge, where we've seen that compared to other industry standards to produce proteins, our microdroplets are up to 100 times cheaper than cell-free expression systems, and due to our modular cloning system, we are more versatile than having to engineer a whole new cell strain for a new protein target. And as of last year, we have filed a UK priority patent, published the first ever paper showing these capabilities inside cells, and have received an IAA grant focusing on commercialization of this research. This year, we are working on market outreach and building a library of target proteins, which positions us at a technology readiness level between 3 and 4. And just to show you an example of this ongoing research in these confocal micrographs here, when we don't have our microdroplets present, we have low expression of our toxic protein. Compare this to when we do have our microdroplets, shown in orange here, we have up to 20 times more expression of our toxic protein, shown in green, inside the cells. Our microdroplets can be used by anyone who is struggling to produce a problematic protein, or by those who can only produce the target protein through costly methods. Our system can also be expanded to other high-value biomolecules, squarely positioning us in the next generation biomanufacturing market. This gives us the opportunity to serve clients in biopharma, industrial biotech, emerging startups, and to other academic research groups. Currently, we already have research professionals who can see the value in our technology and want to use it now, reflecting our strong product-to-market fit. And to reach these other market sectors, we are working on building our network, publishing standout papers, attending conferences and competitions such as today, and through direct sales to their sales teams. And another reason customers should adopt our new innovation is our streamlined production pipeline. For timekeeping's sake today, I'm only going to highlight our efficient turnaround to produce new proof of concepts using our system. If you'd like to learn more, I can go over this more thoroughly in our Q&A. As part of the next generation biomanufacturing market, we have a global total addressable market value in the tens of billions of pounds. As we have a broad option of possible clientele, just an example share of this market is 0.14 billion in just one family of toxic proteins. And for these high-value proteins, we can sell them directly by weight. If you'd like to learn more, I can go over a case study for the pricing of an example toxic protein, colicin, in our Q&A. We estimate we need about £500,000 of seed fund to bring our first protein product to market, although this can be reduced if we choose to sell the plasmid designs or focus on IP collaborations, as these have lower overhead costs. And if we choose to create these new research collaboration agreements from our IP, in a hub-and-spoke type model, we can establish continuous ongoing revenue across all these different market sectors I've previously mentioned, establishing us as key players in the field. And at Cambridge Droplet Microfactories, our core team consists of Dr. Brian Ng and I, who are both postdocs in Professor Lorenzo Di Michele's lab, where we're actively carrying out this research. Beyond our extensive scientific backgrounds, all three of us are deeply engaged in entrepreneurship here at Cambridge. We're also working closely with Dr. Richard Lever here at Cambridge, as well as the Cambridge Enterprise team, who are helping us with IP and business development support. And through the Trinity Bradfield Prize, we hope to gain valuable mentorship, strengthen our networks, and if possible, gain a little bit of funds, where 10K can add 2 more months of R&D, which equates to 2 more protein types captured. And with that, I'd like to thank you all for listening. If any of you have a problem producing a protein, please do reach out, and my colleague and I will happily take any questions now.
Quite often with proteins expressed in E. coli, these usually end up in inclusion bodies, which are unfolded and therefore quite often not a problem for the cell because they're not expressing their toxic characteristics. You seem to imply from your diagram that these proteins are fully folded inside your microdroplets. And I'm interested to know whether that's true and what advantage do you think that gives you if indeed they are fully folded and you don't have to refold them?
Well, we haven't tested every single protein out to see if they all fold in their environment. That's the microdroplets. But in the confocal micrographs you've seen, the protein is actually tagged with GFP, and we can see there the GFP folds correctly, and we can see the fluorescence. We still have to do further analysis to see if every single protein actually does fold in that environment. But
GFP is expressed quite well inside bacteria anyway.
Yeah.
So you haven't actually differentiated between what would normally happen and what's happening with your system.
Yeah, like I said, we still need to do more characterization inside the cells, but we have done some in vitro studies using other enzymes, other proteins and enzyme pathways, and we can see that they carry out perfectly well inside in vitro environments, and we'll see if it works well inside the bacteria.
Okay, thank you.
Next up, we have Camilla from Degranova Therapeutics.
Good evening. My name is Dr. Camilla Scanelli. I'm from Degranova Therapeutics, where we aim to drug the undruggable cancer targets. So drugging the undruggable is a phrase that has been commonly used in the drug discovery space, and that's because only a small proportion of proteins that cause diseases has actually an approved therapy against them. When we look at cancer-related proteins, only 5 to 10% of cancer-relevant proteins have an FDA-approved therapy against them. And so to expand the druggable space, what has been shown is that if you have your target protein of interest and the cellular machinery that degrades protein and you bring them together, you can induce degradation of your target. But if you can't bind it, you can't degrade it. And indeed, 60% of small molecule drug discovery programs fail due to an inability to bind the target. And so there is an intrinsic full promise of small molecule TPD approaches to expand the druggable landscape. At Degranova, we target these undruggable oncology targets by combining protein engineering and gene therapy. And to show that this is a viable therapeutic strategy, we've gone after one of the most notorious and challenging oncology target proteins, MYC. MYC is an essential, non-redundant node with no current FDA-approved therapy, although it's been studied for over 50 years. So by delivering biological degraders as gene therapy, we're tapping into the global total pharma and venture investment of over $11 billion. And whilst the small molecule TPD space is extremely crowded with all the major pharmaceutical companies having asset in development, the biologics-based TPD space is wide open. And depending whether you're delivering your TPD approach as a peptide or protein therapy or a gene therapy, you have even more opportunities. Our product development has gone through a platform development, which has been patent protected, and the assets emerging from it also are patent protected. We've done proof of concepts in vitro and in vivo, and we have seen tumor regression within 10 days in lung cancer mouse model when we degrade MYC. We are currently developing a therapeutic prototype taking us to TRL3. So our customers are lung cancer patients, but we have the potential to expand beyond this because MYC is deregulated in over 70% of cancers. But by focusing on lung cancer patient, we're trying to address the biggest clinically unmet need. And this is because lung cancer is the leading cause of cancer death in the UK and worldwide, with mortality rates that haven't dropped in the last decades. This is because 70% of patients fail primary first-line therapy, and this drug-induced resistance arises within 5 to 6 months. By being in Cambridge, we are uniquely positioned in a centre for Cambridge Research Excellence, which is exemplified by the Cambridge Cancer Research Hospital investment. And throughout our therapeutic development, we will engage with patients as well as healthcare professionals in this outstanding and unique ecosystem. We want to de-risk IND development with strategic pharma partnership, and we will aim our therapies first at the 20 to 30% of global annual lung cancer cases that can currently not be addressed with small molecule drugs, which is about 500,000 cases per year at $100,000 in pricing, which is an average of biologics-based therapeutic. Assuming 10 to 20% market penetration, that would take us of a sum of 0.5 to 1.5 billion US. We are currently an academic-based endeavor, so the Trinity Bradfield Prize can offer us a lot, but our main goal with this competition is to build a network that can help us develop and scale our innovative biologic-based therapeutic to IND ready. Our team leverages academic expertise and industry expertise to bring Cambridge excellence to TPD field. So this is based on a collaboration with AstraZeneca that's been going on for a couple of years now. And the team is composed of myself. I'm the research lead. I have a background in TPD and cancer biology and gene therapy. And Dr. Catherine Wilson, who is here. She's an expert we're leading expert in cancer biology, MIC, and gene therapy. She's here if you want to talk to her later. Professor Laura Itzaki, who is an expert in TPD and protein engineering, and Dr. James from AstraZeneca, who's the Director of Biologics Engineering. And together we have a strong scientific foundation, an exclusive IP, and a strategic pharma backing that has allowed us to gain significant funding, but we want to take this beyond the university bench into a university-led spin-out. And for that, we will look for regulatory and translational expertise to join our team to take us to R&D ready. Thank you very much. We are Degranova, and together we will degrade undruggable cancer targets for improved cancer survival.
I think I understand correctly that you're going to deliver your drug as a gene therapy.
Yes.
Have you decided exactly what your delivery mechanism is going to be?
This platform was originally developed as an mRNA-based platform, and this is where our expertise within the lab currently stands. We are currently delivering it as linear mRNA because mRNA has a wide benefits compared to other gene therapy approaches. It's scalable, it's transient and programmable, and it's safe. We're currently exploring other modalities of RNA structure, so like circular RNA or self-amplifying RNA, to extend the longevity of our therapeutic. But yeah, RNA is the way we think we should go.
And who do you think is leading in the field of delivering mRNA? Probably US labs. Who is your main competition?
Well, with mRNA, Moderna, they have quite a repertoire of patents within that. Yeah, so BioNTech as well. But they are mostly aiming their therapeutics at cancer vaccines. So by diversifying and including the targeted protein degradation approach, which is currently mostly explored, as I've shown in the competitor analysis, by small molecule approaches, we don't really have major competitors currently.
Right, so from life sciences, we are now venturing into the space of sustainability, and I'd like to invite Dushan and Callan up to the stage from GreenMixes.
Hello everyone, I'm Dushan, this is Callan. We're the co-founders of GreenMixes. So we've developed an admixture to turn concrete, one of the world's largest climate problems, into a carbon sink. Cement is the second most used material on the planet, but it's also responsible for 8% of global CO2 emissions. So if we truly want to decarbonize the built environment, we have to consider cement. And more importantly, we have to rethink it. A good place to start is to look at the Bradfield Centre. It is a flagship of sustainable design and yet still required 8,500 tons of concrete. It's not a design flaw. It sort of shows how difficult it is to move away from traditional materials, even when sustainability is the goal. And today, contractors are having to deal with demanding sustainability criteria to win tenders. And without viable alternatives, many are simply just being priced out.
So with the push towards sustainable materials and concrete at the center of this, we're finding that there's more and more disruption in the area. All the most promising solutions have slight issues, though, from high capex, low material availability, or they are just not cost competitive at scale. When we spoke to key stakeholders, they all said the same thing. They don't want their factories rebuilt, and they really value unit economics. With this in mind, we think biochar-based solutions are the future. Biochar is a biomass waste product and stores carbon permanently in the environment. And it's already being produced at the gigaton scale. And with this, there is a real drive for a scalable use case. But there's a reason why biochar hasn't been used in cement, and that's because it performs very poorly. It acts like a sponge. It absorbs water and prevents cement hydration. And what this means is that the compressive strength and the workability are dramatically reduced. And these are the two crucial parameters for our customers. As a result of this, biochar solutions currently can only load 1 to 2% of cement and resort to expensive milling techniques to make their product, which often increase cost by up to 40%. So with this in mind, we designed GreenMixes to eliminate all these issues. No dry milling, improved workability, 3 times higher cement loading, and also 50% stronger than conventional biochar methods.
We utilize a proprietary process that we're hoping to have patented by Q2 this year to produce a biochar composite that's been functionalized specifically for cement systems, that allows the admixture to plug directly into existing cement and construction supply chains without the need for new infrastructure or additional capex by our customers. This is because to produce a GreenMixes brick, we're not deviating away from how to produce concrete. We're simply just changing the composition. In order to produce this brick, all I have to do is seamlessly blend the admixture with the 4 core components of concrete, cast, cure, and you're done. Nothing has been changed. It's still concrete. And the nice thing is we're able to produce enough admixture now for ton-scale concrete production.
So our beachhead market is concrete pavers. They're low structural regulation and require low compressive strength. And as a result of this, it's the perfect place for us to test our product and then have a quick product that can be then integrated into market. And as we engage with the certification, we want to move increasingly into more structural and highly regulated applications, eventually breaching into the 900 billion ready-mix concrete industry. So our team has backgrounds in chemistry, material science, and advanced manufacturing. And with this, we've been able to take this product and develop it from TRL 1 to TRL 6 in just 6 months. We've also recruited Professor John Orr, who's the leading expert in sustainable material construction. And we're also looking for additional advisors with in-depth knowledge of cement procurement and distribution channels. We've also secured our supply chain with 3 biochar producers already committed to giving us 1,000 tons of biochar on fundraising. We're working with the Materials Processing Institute for third-party verification, and we're also finalizing our patent. And with this, we're in in-depth pilot discussions with key stakeholders across the value chain. And it's now the time where we need to give them material in hand so that we can do our pre-pilot validation trials.
And this step is exactly what the Trinity Bradfield Prize enables. We'll be using majority of it for producing 15 tons of the GreenMixes admixture to help support real-world evaluation with existing partners while seeding future interests. Whether that means building benches in colleges or simply paving pathways, we'll do it. We want to get engineers, councils, contractors to be able to touch it, test it, and be able to talk about it. All of this is about driving visibility, credibility, and ultimately converting the existing interest into demand and then de-risking GreenMixes ahead of a pre-seed round later this year. And with your support, let's build a carbon negative future together. Thank you.
Thank you very much. That was super clear. Just a couple of questions on this one. I think for me, it would be understanding your funding journey that you see ahead and really sort of working through the regulatory hurdles you may have, just to get a timing for how long between each of those stages and what you have to prove with that regulatory complexity as you progress.
Yeah, thank you for that question. So often with regulatory, at least in this field, BBA is kind of like the main accreditation service we would have to do. A lot of it is giving them essentially samples for them to do compression tests, durability tests, so on and so forth. Those tests actually don't take too long. It's about maybe a year. Most companies do take about 2 to 3 years to get full certification, but that's predominantly because of QMS, right? Once you have to get that quality management system, it's a tricky one for us right now because we haven't expanded enough where we have like I guess we 100-liter processing plants and that kind of stuff. So that's where it's a bit difficult for us to generate a QMS at the moment. Certification testing, that we can do early, but then it's raising money to essentially build a factory and then putting quality assurance markers and getting that validated. That's where majority of the time will go. And to be fair, I mean, we've been entering the various competitions around the Cambridge market to kind of figure out when do we raise for that bit versus just the pure technology, so on and so forth. So it is a bit of a work in progress.
Thank you. And a quick one on your pre-seed round later this year. What size are you thinking of that?
I guess
Still to work through.
Very much is dependent on these pilot scale studies. So if we can get that validation, then kind of we're looking at a higher raise, maybe in the 2 million plus. But if we can't get that commercial traction, then maybe we need to kind of test the market in a smaller raise of maybe 500,000.
Thank you so much.
Great.
Right, from the world of construction, we're going into the near future of computer-aided visualization, presented to you by Anita Vero from Latom.
Hi everyone, I'm Anita, and we are at Latom are building the next multimodal AI interface. So today, generative AI and agentic AI is everywhere, so is the hype. Yet, when it comes to the adoption of AI models in professional settings, that's seriously lagging behind. This is especially true when it comes to visualizations. We spoke to 80+ experts, visual designers, learning designers, and they all complained about the same thing. The inaccuracy and inconsistency of today's models prevent them from using them in professional settings. The context window limits prevents them from keeping a consistent brand identity or theme throughout a whole course or slideshow. On top of that, companies need to meet strict data sourcing standards, and the creative industry is all worried about copyright issues. Even the smallest companies that we talk to end up spending thousands on manual visual design and complicated workflows. The graphical user interface was what brought early computing out from the university labs to now everyone's pockets. In order to gain the same efficiency level with AI, we need to reimagine the interface between the human computer again and between the human and the AI. This is what we do at Latom. We solve the inaccuracy problem with a completely new dynamic adaptive user interface. Moving beyond the static chat window, what you can see here as an ideal user, for example, a learning designer or a graphic designer, can interact with a Latom AI agent, which acts as it was a junior partner. You can talk to it, text to it, and it can help you with generation. But on top of that, everything what you see here is not an embedded static interface, but even the visual interface is generated, and you will see as it changes, as it adapts to the task. On top of this, the agent sees everything that the user sees. It tracks the entire project, and this has dual purpose. First of all, it can generate more consistently throughout an entire project. And secondly, it allows us to do proper data provenance following licensing and copyright issues. We spoke to several experts and professionals across various sectors, from educators, UX, community management, and publishing. Our beachhead market is publishing, especially in learning design, with early partners such as Cambridge University and Press and Assessment, who helped us immensely with their feedback and example data. We have letter of intents from learning platforms such as Einstein Horizon and Teach Me series. But since we are building something that moves beyond visualization, that opens the door for us to other segments such as movie and art production, marketing, and game design. We are the finalists at the UKRA Agentic Prize for the creative industry, and that really helps us towards this expansion with mentorship and computing already. So we get early funding from Cambridge Enterprise, and from this 20K funding, we already built our working prototype, and we are pushing towards our beta release. We are following the now standard multi-tier pricing structure, accounting for increasing GPU needs, and our estimated revenue for year 2 reaches 2.5 million. Accounting for corporate training and e-learning markets, our obtainable markets is much bigger than that. It reaches at least 220 million. We are very much looking forward to the mentorship that the Trinity Bradfield Prize can offer. And we would use the 10K funds to push us towards releasing our beta. It would cover UX, marketing, and staffing costs. So I've been in AI in the past decade, did a PhD at Cambridge, have been working as a research engineer several places, and I created my previous AI company with which I helped dozens of companies with their responsible and efficient AI integration. With Latom, I wanted to bring this mission and scale it globally. I'm privileged to be joined by 2 of my co-founders, Haritha and James. Haritha is an expert in AI for 3D vision and also a seasoned mentor. And James is also an expert in machine learning infrastructure, having worked at places like the Alan Turing Institute or NASA. We all share machine learning and also education background. And another thing we have in common, even though we come from very diverse backgrounds, we all had access to high-quality resources and education while growing up. With Latom, we are on a mission to bring the advances that AI brings to the majority. Thank you very much. We are happy to answer any questions.
There's massive markets out there. How much are you going to need to customize to address your market? And how much is going to be very much a standard product that you can sell?
The idea is that the product is able to be standardized to, right now, predominantly learning design, and that's what the expertise that we've been tending to learn. And the UI itself rebuilds itself as needed for individual tasks. So the bounds of that right now, we are mainly maintaining as learning design. And there's a lot we've learned in terms of all the different needs that they have in this space, and a lot of it's because there's so many different tools, there's so many different workflows, there's so many different things that we would be able to effectively either bring together or at least communicate with, because one of these things, one of the benefits of all the recent advances in these base models is the ability to glue things together, and that means that we can operate as either that hub, but also build what's needed for the user as they are also going through the creative process of discovery.
Next, we're venturing into marine sustainability with Maricene and Keshav.
This is Keshav from the Maricene team, where we are reinventing how fuel is produced. So we are doing so by producing a renewable fuel from seaweed residue. And to understand why, let's look at the big picture. So we all know the problem. Fossil fuel use and transport is driving climate change. So what did the world do to try to fix this problem? We turned towards biofuels, fuels made from food crops. But it turns out using food crops that require a lot of fresh water and land to grow is not sustainable. And it has led to problems such as supply not meeting demand and regulatory pressure to switch towards non-food-based fuels. So this is where we come in. We realize that the seaweed industry, which is growing year by year, is producing a massive amount of residue that they are currently paying to send to landfills. So we have developed a proprietary yeast strain that can convert the seaweed residue into a biofuel. We have produced this bioethanol at a lab scale and now are ready to scale up. And the bioethanol that we produce is differentiated from the competitors because of the feedstock that we use. The seaweed residue, because it's already pre-processed, it reduces our production costs. And unlike the food crops, we don't require any fresh water or land to use the feedstock. And finally, because we are using a waste-based feedstock, we get additional regulatory benefits. So our primary customers are wholesale fuel distributors, be it big players like Shell or BP or local fuel suppliers. And switching to our bioethanol would mean that it will lead to significant cost savings for them. And it will easily integrate with the existing infrastructure because it's fungible with conventional bioethanol. And it will promote their ESG values. And to commercialize the product, we'll follow a three-step approach. So first of all, we'll participate in industrial conferences and trade groups to increase our visibility. And based off the interest from that, we will then conduct site audits and demos. And finally, we'll sign offtake agreements. And offtake agreements are just agreements where the customer decides to buy a certain portion of your future produce. And as in terms of traction, we have secured a letter of intent from a local fuel supplier, which is the Anglo-American Oil Company. And as I mentioned previously, we will generate revenue through the offtake agreements. And if you look at our unit economics, we will price our bioethanol at a similar price to conventional corn-based bioethanol, while still maintaining a healthy margin, as seen in the bar chart over there. And assuming that these waste producers are willing to pay a certain amount, we can also add a small a gate fee. And if you look at the market size, the global bioethanol market size based on a certain type of alginate residue is around 32 million pounds. And if you go down to a local level, for example, in Scotland, that is around 400,000 pounds. So our roadmap is clear. We have already produced this bioethanol at a 5-liter scale. Now we want to conduct a small pilot where we will test it at a 50 to 100-liter scale to test the efficiency of our strain. And then we'll scale up to a 1,000-liter scale for a demo, and then to a commercial scale, which will be 1 million liters. So winning the Trinity Bradfield Prize would be helpful for us because we can use the prize money to patent our proprietary yeast strain. And also the media coverage that we'll get through the winning the prize will allow us to attract investors for our scale-up studies. And if you look at the total waste pool of seaweed, the industrial waste pool is actually just makes up 6% of the total waste pool, and the 94% is actually made from invasive seaweed blooms in the Caribbean. So in case we are not able to secure all of the feedstock, we can then use the other waste feedstock too. So we are the right team to solve this problem because I bring in the business development skills through my experience of working in a sales-oriented role in an early-stage startup. And I also understand the mechanics of venture building through my time at Cambridge Future Tech. And my co-founder, Farhan, he brings in the technical expertise. He developed this technology as a part of his PhD at the University of Edinburgh, but we own 100% of the IP. And we are backed by an experienced team of advisors. So our advisors bring in expertise from the environmental and the business sectors, whereas our mentor, John, who is a partner at a climate tech VC firm, is helping us become investor ready. So we have realized that once we scale up, we will need to make strategic hires in engineering and the finance department to fill in the gaps that will be made. And our long-term vision is to have a global network of these biorefineries that can convert seaweed residue into sustainable energy. And we are looking to collaborate with industry and supply chain partners. So please feel free to contact me to the email or the LinkedIn QR code below. Thank you.
You kept referring to, I think it's a great idea to ferment seaweed, but yet you kept referring to seaweed residue.
Yes.
And that implies there's been some other process that's taken place on it. And I'm just kind of wondering whether the seaweed residue market is enough to sustain, what is that residue? What is that process that you've already had to do to the seaweed?
So currently the seaweed industry, we use it to extract carrageenan from seaweed, agar, and alginate. So what is left behind is actually cellulose and hemicellulose, which is what our yeast strain uses to convert into ethanol.
So if you had to go directly from kelp, for example, you would have to do some extraction process first. And how much does that add to your economics?
Yes, definitely. If we use kelp directly, then we would need to use an hydrolysis process that will add a bit of maybe 5% to our cost. Yes.
Only 5%. Okay, thank you. It's very helpful.
Yeah, okay.
Thank you.
Right, from seaweed biofuels, we're venturing now into exploring the wider area of global climate risk, and the economics of pricing such things. With Omer from Otzi.
Hi everyone, I'm Omer, CEO of Otzi. We are doing accurate climate risk for correct pricing for insurers. The problem we are tackling is both financial and human. The insurers industry loses around $100 billion annually by mispricing climate risks. And the trend is growing. And it's not that the risk is unmanageable, it's that it's poorly modeled. And what happens because of that is insurance companies and reinsurance are pulling out from areas and leaving the most vulnerable people unprotected. So the cost is on us. And this is where Otzi comes into the game. Our solution offers the first physics-informed AI model to predict future climate hazards up to 2050. We are 30% more accurate on different metrics regarding temperature, precipitation, and wind. It's 10th of the price to produce for us and 10 times faster, so highly adaptable. And this is in compare to the leading players in the industry, Moody's and Verisk. The current approach is to use antiquated statistical models that can't handle the dependency between different time points, exactly what we need for events like heat waves. The picture you see to the left is an example of the output from our model. The number of heat waves in Abuja, Nigeria, for the last 20 years. The vertical dotted blue line is the observed number of heat waves. The light blue histogram you see around it is the model from Otzi, from us, and the others is industry, state-of-the-art, and academia. Our technology is peer-reviewed and published. So Otzi wants to be part of the insurance revolution, from short-termism to long-term resilience, from just checking what is the historical record telling us to actually looking ahead on predicting climate hazards and putting it into decision-making. Instead of pulling out from areas, actually having targeted adaptation to reduce risk and more potential products via parametric products or multi-year products. If the risk is known, we can price it. The insurance market is estimated by Verdantix Research to be around $4 billion, where we think we can obtain around 30% of that. This is based both on adoption curve of new technologies and on our conversations with many, many people in the industry and the appetite we see for our product. There are other big industries that show interest in our products, but through our ecosystem here in Cambridge and our work, we have tapped into the insurance industry first. The business model is simple and scalable. So it's a flat rate, yearly subscription, $100K to $1 million, depending on how many climate perils you are interested in and the geographical extent of that. Customers, based on the 30% figure I discussed earlier, this would be 500 to 750 customers by year 7. In the first year, we just want to capture 5 to 10 clients to prove and validate our approach. And we're going to offer it in a high discount where the rest of the amount will be in-kind contribution. If we get this amount of customers, the revenue by year 7 can be around 300 million. We estimate the revenue in year 1 to be 50K and break even by year 3. We already have traction. So we have letter of intent from Verdantum, a company co-owned by Roger Ferguson, ex-vice president of the Federal Reserve, for a paid project for heatwave mortality in Africa. We won some prizes, AI at Chem and the Postdoc Venture Capital Challenge. We have an offer for early investment from Mike Griffin, and we are in discussions with 3 global reinsurance companies and hoping to secure our first paid pilot with a climate intelligence startup. We are asking today the 10K for the Bradfield Prize, and we want to use it to host an event with Cambridge Centre for Science and Policy on the future of pricing climate risks. This will bring together industry players, regulators, and policymakers, where the objective is to actually tailor our product to client needs and hopefully win the first few customers. we are also looking for an advisor that speaks insurance, because this is not our area of expertise. Thank you very much, and please join Otzi to make climate resilient future.
Okay, thank you very much. That's very interesting, and it's certainly a good approach to this.
Thank you.
I think for me, the concern would be the go-to-market strategy with this one. It's got to have such an impact for an insurer to want to put this into their systems and integrate with their existing systems. So I think that's my lens from here. What does the product look like? Who is the person that's actually going to be using this? What is the user profile here? And what does that product actually do in conjunction with their other risk analytics and predictive products? Yeah.
So we've been discussing with people from the insurance industry that our ideal customer is insurance or reinsurance that don't have modeling in-house, and they are interested in long-term projection of climate.
Can I just ask a question on that?
Yes, of course.
That don't have modeling in-house?
Yes, this will be our first target audience. Okay. For example, Howden Reinsurance is an example for a big company that don't do it in-house, and we've been discussing with. And they would be, they already purchased this from third parties. And so this would be a great opportunity for us talking with the climate risk team, catastrophe modeling team, where they would then take it and move it to the actuaries to price the premiums. So that's, we are also aiming to sell it to ones that have modeling in-house, but there I think the entry point is a little bit, the cycle is a bit longer.
Like the climate risk that Omar is trying to predict, we're swinging wildly back into the space of medtech and improving the life of people with Parkinson's, with John from Peter.
Good evening. My name is John Fisher, and I'm the founder of Peter Neurotech. Peter's my father, and when I was at university, he was diagnosed with Parkinson's. I became so frustrated watching him suffer that I decided to invent a device to help him walk again, and that journey has led me to where I am today. So, when most people think of Parkinson's, they often think of shakes, but one of the biggest problems is actually falls. 68% of people with Parkinson's fall every year, and one of the big reasons why is what I'm about to show you. When you've got Parkinson's, your legs will randomly stop working, and they will become glued to the floor when you're trying to walk. This leads to severe falls, life-threatening injuries, and creates a huge burden and impact on your quality of life. Now, one day researchers decided to look into this phenomenon called freezing of gait, and they put lines of tape on the floor. And just with the lines of tape, nothing else, they found that this man could walk. And they played a rhythm, and they found again that just like a soldier marching, this man could follow this rhythm perfectly. And so what you've seen is called a cue, and a cue allows you to overcome freezing without requiring any medication. Cueing can be visual, like lines of tape, it can be audible, like the noise you just heard, or it can be vibration or touch. Now, when I was at university, I saw this, and I decided to try and take this research and give it to something for my dad. So I worked on a wearable device that played those noises that you just heard in a discrete, invisible manner in real time. The concept itself won several awards and featured two prominent parts. The first is this blue part of the neckband, and the second is a sensor on the shoe. The neckband used bone conduction, which is an existing technology. What that means is it allows you to hear those noises in an invisible manner, while also allowing you to hear your surroundings at the same time, giving you greater situational awareness and safety. Secondly, the sensor tracks freezing instantly, playing the noise only when you need it, using existing wearable technology. Now, our current form and our current prototype in terms of the design has changed, but the core concept remains the same. And since leaving at university, I've secured £48,000 in non-diluted funding to take this project further, primarily £40,000 through a grant with Cambridge NeuroWorks. Currently, we're TRL4, and we're actually performing our user testing with people with Parkinson's in the Bradfield Centre this Friday, which is incredibly exciting. When you compare Peter and what we're doing to the existing competitors on the market, it's quite an interesting approach. Certain competitors use visual and audio cues like we just saw, which means that they are effective, but very, very obvious to everyone around you. So people like my dad would never buy them. The second part of competitors use vibration, which is discrete, which is a fantastic way of doing it. But the problem is it doesn't have as much clinical efficacy at overcoming freezing episodes. So there's a real gap in the market for a solution that is discrete and effective. Using bone conduction gets the clinical efficacy of audio with the discreteness of vibration. No product on the market is currently using bone conduction, and I've got some appendix detail as to why we think we can defend that and scale it. Now, we truly understand our customers and we validated the problem here. I think our name sums it up best, Peter Neurotech. It starts with the user first, right? We've spoken to over 100 users and they are the core of everything we do. They give us iterative feedback on our design and they ensure that we create something that will be adopted and loved. Through my Cambridge NeuroWorks Fellowship, which is powered by ARIA, I'm given the clinical guidance to ensure that hospitals and clinicians can actually use and purchase this. And additionally, through partnerships, we aim to actually reach both the direct-to-consumer and the B2B sales. Partnerships will help us support scaling, build credibility, and hopefully reduce CAC costs through marketing. Our plan to market is that we're going to launch first as direct-to-consumer and then focus on getting traction and then healthcare adoption. The reason why is that we feel that if we launch first and generate early revenue, we can raise a greater fundraising round that will allow us to get into medical procurement. It also means that we can make a quick impact on the people that need it first and avoid the lengthy procurement protocols while trying to be bootstrapped for cash. The benefit of launching early, however, is the data that we can get from the sensor, because that means that as the adoption grows, our data set will grow, which provides the foundation for us to improve our future products and potentially collaborate with researchers and other institutions to help use it as a foundation for Parkinson's research. There's a huge need for this. Currently today, the market is valued at 335 million. In 10 years from now, it's going to be 820 million pounds. And diagnoses are 10 million today worldwide, 12 million in 10 years, and by 2050 expected to be 25 million. For us, we're very confident in our approach, and we're hoping that our feasibility study this Friday is going to highlight our confidence because we are translating proven concepts into a user-friendly package. We are taking existing technology that is scalable and accessible and putting it in a manner that our customers will love and adopt and use. Currently, right now, we're getting our proof of concept data, and we're hoping that with that first part of data that will show TRL4, we can get future grants and scale more. Our long-term goal is to then go to pilot studies out of the lab and secure the necessary foundations and protections we need to scale. The problem we've got currently is that the majority of our funding, which is through the grant, can only be used for R&D. We can't use it for business expenses, which is why the Trinity Bradfield competition is so essential for us. Because once we get this feasibility data, we need to ensure that we have the right mechanisms to protect our device and also scale it and have the foundations and the corporate knowledge to grow. I started this company in September 2024, a week after I finished my master's degree. Since then, I worked on it 6 months for full time before I received my first bit of funding, and I've hired 2 fantastic people who helped me along the way. We have someone like myself who has a core understanding of the problem and the ability to design solutions that will be adopted. We have Campbell, who unfortunately is in Texas today. God knows why it's so cold, but he's there. He supports with technical development and he does a PhD building AI models in the Royal Papworth Hospital. And then we have Naya, who's recently joined. And Naya used to work for a direct queuing competitor before they unfortunately went out of business. And she's helping us with our marketing and our value propositions. We intend to go the distance with this. We need to launch this and we need to help people like my father, which is why we need your support, we need your mentorship and we need your guidance in order to bring this to the market and help people like my dad walk again. Thank you for listening.
Can you explain a little bit more about the journey that this product needs to take? You're going to do a feasibility study. Is that just with your device? Are you going to compare other devices? Is there a regulatory path? How many more kind of tests do you need to do before you can start selling direct to the consumer?
So a big part of that depends on what strategy we go for how we actually regulate our product. So we can either go down a wellness route, which is what a lot of, say, consumer goods do, or we can go down a medical device route. What we're trying to do is, I know this sounds ridiculous, but at the start we're going to copy toothpaste. Toothpaste isn't a medical device. Everyone thinks it is, but it's not. And what they do is they market toothpaste by saying 9 out of 10 dentists will recommend this, and our studies show that it reduces plaque in such a way. The reason why I'm saying this is because we feel that if we launch it as a wellness device, and we do these feasibility studies and the pilot studies to get the data, we can streamline a lot of our development, and we can launch something with confidence that we know it works. Instead of spending 5 years like our competitors are doing to release a medical device, to then have to then, once they've launched it, then spend another 2 to 3 years procuring it. Our strategy's really been looking at our consumers and our competitors and learning from them.
Right, from Parkinson's, we're now venturing into the hard tech space of photonics and how it will enable the next generation of quantum with Philip from Phaseshift.
Okay, hi everyone, I'm representing Phaseshift. My name is Philip Cloud and we're miniaturizing optics for quantum and photonics. Oops. So the problem we're trying to solve is that current industry optical systems use conventional components that are really sensitive to the environment. These result in large and fragile systems. A market we're directly addressing is quantum computing. This is an example of a quantum computing system with around 250 qubits. Now, the quantum computing space is really trying to revolutionize areas such as drug discovery, optimization problems in finance and logistics, but they're stuck. By 2030, these companies want to reach 2 million qubits to try and reach those lofty goals they've set themselves. But that would require 8,000 of these 4 by 2 meter tables and individual control of every component in the system. That's inherently unscalable and unsustainable. So our solution is ultra-compact and multifunctional metasurfaces to offer 10 to 100 times miniaturization of these optical systems. Metasurfaces are thin films patterned with complex structures. Our submicron optics are manufacturable on a wafer. They're around a micron thick and offer lithographic precision over the parameters. Importantly, our technology is compatible with existing foundries, so we can go to a foundry in Asia, in Europe, in the UK, and build our devices there already. We don't need fancy new machines. This all results in fewer components that are more robust, with increased precision, and we can build scalable optical systems. Our proprietary technology is twofold. On the software side, our reinforcement learning-based design algorithm means that we're not constrained to conventional designs that use standard geometries. We can generate organic freeform structures, and this results in devices with improved efficiency and performance over the current technology. Additionally, we can do this for a diverse material set. Current competitors use silicon, which is stuck in the infrared range, so they can only serve the AR and VR sectors. With our diverse capability to work on different materials, we can address more wavelengths in the visible and UV spectrum for industries like quantum, biomedical imaging, and UV spectroscopy. And we have the patents to show that and protect our space. We offer the full stack, so we go from design to prototyping, fabrication, integration with customer systems, and we've proven this with real-world customer traction and achieve milestones that these customers have set up for smaller projects. Our current revenue stream is through co-development, where it's project-based. So we work with a customer on a small project to prove a proof of concept, and then we scale that up. This helps us to develop our foundational IP and generate funding for internal R&D. We'd like to move towards pilot production and mass manufacturing. This will help to validate manufacturing at scale and also de-risk the supply chain needed for that. We'd like to move in the future towards a more capital-efficient scale, where we can use IP licensing fees and sales to generate recurring high-margin revenue. Our partners include Cambridge Enterprise, NIST, and we're currently working with Cornerstone, which is a foundry in the UK. How we stay ahead is through, one, our expertise and experience. We have direct experience working with and for the world's leading quantum computing and sensing companies. We know firsthand where the problems are and how we can solve them. We're Cambridge-based, which has an unrivaled ecosystem in semiconductors, quantum, and photonics. New Quantum is a collaborator that we're talking with. They're 5 minutes from my office. Wave Photonics generate design kits for photonics. They're 5 minutes from the Bradfield Centre. It's recently been designated as the #1 quantum cluster globally by the European Centre for Policy. And most importantly, we're built for scale because our technology has foundry compatibility in mind. The market opportunity for the end market is relatively large at around $30 billion. And we think with our current technology, we can address around $500 million. Because we're one of the first movers in this space, we are confident that we can take a sizable chunk of this. Our current and potential customers are not just limited to quantum, however. Our beachhead is quantum technology companies in the computing and sensing space, but we also work with display tech companies, and we're filing patents in the medical imaging space as well. This is the photonics decade, where photonic-enabled systems can reach up to $1.7 trillion in economic global value. And the most important part of the company is our team. Myself, I'm the UK director here, and I'm a first-year PhD student at Darwin College. My supervisor is Dr. Amit Agarwal, who's in the audience today, and he's a professor here and fellow of Trinity College. I worked with Reslind at Quantinuum, one of the world's leading quantum computing companies, and has its roots in Cambridge. And we recently hired Sean, who is an expert in optical simulation. The Trinity Bradfield Prize will really help us with the network and the initial funding it provides. It will support ongoing R&D, where we can rent fabrication facilities and leverage the Cambridge ecosystem. There are 3 amazing clean room centers here in the Ray Dolby Center, the Graphene Center, and Nanoscience. The Cambridge Enterprise Network of people who have worked in semiconductors, quantum, and photonics will help us to understand how we scale in the UK and globally. And it will help the money will help to go towards going to conferences and events and meeting potential customers and partners, which is ever expanding with programs like the Quantum Technologies Program and the National Quantum Computing Center. Thank you for listening.
So if I've understood correctly, you're going to start off by making custom designs for metasurfaces that customers want, and then eventually you're going to make standard product that you will sell of particular metasurfaces. Is that right?
Yes, that's correct. Yeah.
In which case, there are so many different markets and applications you could go after, and you listed quite a few. What sort of properties and where are you going to start? What are some of the first metasurfaces that you're going to make, and what will their properties be?
Okay. Yeah. So metasurfaces are extremely multifunctional. So we can design multiple different optical components. Some of the initial ones are like lenses. So in AR and VR, people use metasurfaces for enhanced facial recognition. Now we can do, say, lensing of smaller subject matters like bacteria or other small biomasses. And so we can use just the optical concepts that are needed there directly. We can also do polarization control, which is important in cameras and other imaging. Our background, so our main background is quantum computing. Quantum sensing is very similar, so we can translate to that. But we also have background working with thermal imaging cameras as well. And yeah, that's it.
So lots of different applications.
Yes, yeah. Really, so our main market is quantum computing, but we're revolutionizing the optical industry to get there to help them. So fundamentally, we're about optics. So in the future, we'd like to be as many places as possible.
Great, thank you.
Thank you.
Now, for the finalist pitch of the evening, I'd like to invite Yati from Replicam onto stage to give us actually a glimpse into the future of healthcare and organoids.
Yeah. So before my pitch, actually, I want to distribute some of my models I made. These are the organoids on chip models, but there's no living cells. Okay. So they're just structured models that you can check what the structure is. So if you want, you can just take home as when need. Hi everyone, my name is Yati Shen. I'm the co-founder and CEO of Replicam. So it's my pleasure to be here introducing our company to you. Our story begins with neurology. Do you know how many people are affected by neurological conditions in the world? Over 3.4 billion people. That's over 1/3 of the world population. We're trying to find drugs for them. We spend billions of pounds, we sacrifice millions of animals every year to test drugs, but what we got? Over 94% of drugs then fail in human. This is a clear message that animal models are not correct in the case of human neurology. So if we keep using them, it is not science, it's more like a gamble. We're very lucky to see this historic change, which regulatory bodies are trying to phase out animal tests, and UK is setting a key deadline in 2030, which is just 4 years later. So this increased urgency for us to develop the more accurate and human-relevant models. So what's the current best biological model of human brain? The brain organoids. They're actually lab-grown mini human brain that can be developed using your own skin cell to represent your own brain. They're doing very good in disease modeling and drug testing, but they're very difficult and time-consuming to make. For researchers and pharmaceutical companies that are long reliant on animals, they are struggling to have convenient access to high-quality organoids. So Replicam is here to lead the way. For the first time, we make the complex organoids ready to use for everyone, and we are powering the next generation of medicine. So here is our core product that I just distributed. So it's called Brain Optima. It has 3 major parts: the blood vessel-like channel, the brain tissue-like hydrogel, and the brain organoids, which will grow through from top or bottom through the hydrogel, merging with the vessel-like channel in the center. So why we need this internal channel? It's very important to grow them longer because it can sustain the nutrient supply, remove the waste to keep the neural structure alive. That's why comparing to our competitors who have lower than 50% long-term viability, we improve it to over 93%. It is a very big step towards more representative model of a human brain. So now we have the Brain Optima. How can it reach our customers? We then develop this very unique cryopreservation protocol. And using that, we can freeze down the mature Brain Optima and send to our customers via the global cold chain. And we have a very high immediate viability recovery, over 85%. This means for our customers, when they want to use organoids, they don't have to grow them for months. Instead, they just deep freeze the Brain Optima, and within hours, it's ready to use for assay. More importantly, Brain Optima is actually the first and only fully integrated brain organoids on chip you can find on the market, meaning that you can only find it here in Replicam. So in the past 1 year, we established lots of early collaborations and scheduled pilots with hospitals and contract research organizations and research labs across the world. Basically, our target customers are whoever wants to study human brain and the related drugs. So we target the research labs as the beachhead target. Actually, a very conservative estimation is that we can generate 0.3 billion pounds annual profit just by selling our organoids to research labs, but it really depends on our capacity. So for now, if we can get the 10K support from this price, it will enable us to produce organoids for our scheduled pilots and also create our organoids biobank. So Replicam sits in between 2 big markets, the neuroscience market and the organoids market, which is growing very rapidly because of the regulatory shift. And we adopted a very diverse business model. We sell organoids, we also provide contract research service in-house, and we will also investing in generating our own dataset and our own AI model, which will gradually become our core asset in the future. As for the founding team, I have a PhD in engineering here from Cambridge, and I'm a major inventor of Brain Optima as well. I already spent 1 year after graduating from my PhD to full-time build Replicam from scratch. And I work with a very amazing CEO who is a successful businessman and also a computer scientist. We also have 2 professors from Cambridge as our CTO and CSO. They're leading experts and pioneers who worked decades in these fields, including organ-on-chips, organoids, neurological conditions, and biofabrication. So we do have multidisciplinary expertise to not only engineer, produce, but also commercialize our organoids product. So due to time limitation, you can scan the QR code to visit our website for more information, and thank you for listening.
Within your brain organoids and cells, how mature are those cells?
Yeah. So that's actually is a very big advantage of ourselves. I can show you a comparison to other companies. So if you can check this organoid maturity column, actually for them, because they don't have the internal perfusion, when they grow longer, the organoids, they don't have vessel. So the internal core will die. Then this whole thing is die out, it's very random, you don't get accurate, consistent results. But for us, because of this very soft hydrogel and internal perfusion, we can grow them very mature up to over 5 months till now, but we can try to grow longer. So now we grow up to 5 months without dead cell core, with a viability over 90%. So that's actually our advantage. And comparing to human, it's like a fetal human brain. I don't say it's like adult because it's still very small, but it's fetal human membrane having the cortical structures and all the distinct cell types and genetic pathways that animals they don't have.
So that leads me to my next question, which is if you started off with whatever you're seeding your organoids with from somebody with a neurological disease such as Alzheimer's, could you see the disease progression across an organoid?
Yeah, actually, that's what our CSO already spent decades to study, and this really depends on whether you have the genetic change in your cells. So if you have the genetic cause because your disease is caused by genetic change, then if we take the skin cells and we revert to stem cells, we can build brain organoids that having this kind of Alzheimer's or whatever other neural disease phenotype. Yeah.
So thank you very much.
Thank you, Yachi.
Thank you.
Thank you to all of our 7 finalists with an amazing and a broad range of presentations. We shall move actually swiftly into the next phase, and I shall invite 2 of our recent alumni to give us an update of their company development. Up first, we'll have Henrik Runge from Cambridge Nucleomics.
Hi everyone, I'm very happy to be back today. I won the Trinity Bradfield Prize 2 years ago, and I won the Angel Prize 1 year ago, which makes me, to the best of my knowledge, the winner of the most Trinity Bradfield Prizes in the history of man. And this makes me incredibly proud, especially given the extremely rich legacy of John Bradfield and also the high quality of our judgment panel. So thank you very much for having me back today, and I'm very happy to report how it's been going for the last year. And a lot has changed, and the prize really has changed the trajectory of the company. I'm Hendrik from Cambridge Nucleomics, and we detect sepsis before it kills. Let me talk a little bit about what the problem is here. Molly has survived cancer, but the chemotherapy weakened her immune system. So she developed an infection, and the infection got worse and worse because she didn't have the immune system to fight it. And the pathogens eventually entered the bloodstream, and she developed sepsis and then unfortunately died. And this is a huge problem. 1 in 5 people die from sepsis. So in this room alone, it's more than 20 people. I haven't counted, but it might be 30 or more. So this is a huge problem. And in theory, we can treat sepsis because we have antibiotics and antifungals, but we don't have good tests to detect sepsis early and to detect what the right treatment is. And this is where we come in, because we are developing a 1-hour test that helps you select the optimal treatment. This is what we looked like a year ago. We have developed this technology for our sepsis test from the ground up. My scientific co-founder, Ulrich, is a professor at Cambridge University in the physics department, and he's a world-renowned key opinion leader in nanotechnology sensing. We had just been joined by John West as an advisor, who is the former CEO of Selecsa, which is now Illumina, and Richard Pamy has been supporting us from the beginning since foundation of the company. However, following the award of this prize last year, we were able to close our pre-seed round with actually several of the investors in the audience today, so good to see you again. Keep that thought. And we have been able to extend our team drastically. You may recognize John, who has joined as director. Together with Max, both of them have significant experience in commercialization and fundraising. Our chair, Tony Cook, has 40 years experience of commercializing diagnostics tests. And we have hired 3 scientists. These 3 scientists have validated our core chemistry over the past year. They have validated our core chemistry. When you look at sepsis, that is really a needle in a haystack problem, because you have hundreds of millions of human cells, but only 10 pathogen cells, and these are really hard to detect. So to solve this needle in a haystack problem, Melanie, our sample processing lead, has been reducing the amount of hay so that the needles are easier to find. She has enriched our pathogen relative to the background by around 1,000-fold. Gerardo is our nanoassay lead, and he is increasing the amount of hay that we can tolerate and still see the needles. So he is improving the nanoassay or nanoarray sensitivity and specificity. And Rui, our molecular biology lead, he makes sure that we can actually detect many different needles and distinguish the different needles from one another, and make sure that we never confuse hay for a needle, which, given the sheer amount, is a huge problem. And he has designed over 20 probes to detect organisms and distinguish them. However, we have encountered one major problem. We have moved from the physics department to the Abraham Research Campus, which means we're surrounded by life scientists now. And we started talking to them. Wait for where this is going. We have been talking to them a lot more, and they got quite interested in our technology. So not what you have been thinking. They got quite interested in our technology, and they've been asking me, Hendrik, do you think you could solve this problem for me or that problem? And I always say, yes, probably, but we really don't have capacity to do anything besides our sepsis proof of concept, because that's what our funding is for at the moment. For example, this morning we started discussions around a paid pilot for a oncology test, but we don't really have the resources to pursue these further at the moment. And this is why we want to build the platform that underlies our sepsis test to detect an ultra-fast, high-plex RNA biomarker assay. We will detect 200 targets in one reaction in 1 hour. And this is a really good, useful test for many life scientists and across many different areas. And to accomplish this, we are now raising £300,000. So that's why it's good to have the investors in the audience today. Again, we are raising £300 for further platform development to develop the platform and unlock £300,000 of matched grant funding. And this will give us 1 year of runway. So our vision is that we have one portable device, 12 diagnostic tests and lab tool applications, and reach 1 billion patients every year. Thank you for your attention.
So thank you so much, Hendrik. Please go and find and speak to him during the break in the networking to find out about these amazing opportunities. Up first, we have Izo from Healthspan Biotics.
So, hi everyone, I'm Izu, and before I start, I have a question for you. Do you know any friends, family, or loved ones with Alzheimer's? Yeah, lots of nods. Alzheimer's is actually one of the toughest disease, at least for me, it's the toughest disease in the world because you lose your ability to connect with people, right? To form memories, to form meaningful relationships. And one of the unfortunate statistics is that one of my previous papers, I showed that with each year in your life after the age of 40, you have a 13% increase in the risk of developing Alzheimer's. And what that looks like for a lifespan is that you have a 42% risk of developing this hugely devastating disease in a lifetime. So what we are here to do is to try to solve this problem. And we've evolved this precision probiotics to try to deliver some beneficial metabolites to the brain. And I'm going to tell you the technologies behind it. We're basically leveraging the huge amount of data that the last few years in biological sciences have seen. We've looked at different layers of biological information, from the genetics to the metabolites, right? To basically the proteome, the individual protein machineries in the cell, and then going to the single cell itself, of the post-mortem brain tissues from people with Alzheimer's. And then we also looked at, obviously, biomedical records. And we asked a specific question. So what are the mechanisms that are upregulated by the cells to protect themselves against diseases like Alzheimer's? Right? What are the protective mechanisms that the cells are doing themselves? And then we obviously found it. right? We found this pathway that we call neuronal resilience pathway. And then basically we showed in the lab that when we upregulate this pathway, either using metabolites or by upregulating genes in this pathway, we show that it improves the health of neurons. And obviously at that stage, my grandma asked me, you know, we want to treat people. So it's impossible to treat people with these methods that I mentioned. But what is possible is to understand the natural way by which these neuroprotective metabolites are produced. And that is through bacteria in the gut. So we took that bacterial strain, right? We took it in the lab and we evolved it because we know what metabolites we want. So we kept selecting these bacteria for these metabolites. And then we show that basically there is an improvement in how much these bacteria or probiotics are able to help the health of neurons in the disease models. So at that point, we pitched to you guys, and then we told you, okay, if you give us money, we will manufacture it. And I'm delighted to say that we delivered. Okay, so this is the evolved probiotics that thanks to you guys have paid for. So if you want some, I'm still here after. Okay. But then, obviously, what this means is that we can do more sophisticated tests. We've given this to animal models of Alzheimer's, and we see an improvement in brain health, which is great. We also, because it's a probiotics and it's safe to take and it's non-GMO, we also give it to people. And then, because we know which metabolites we want to look for, we were also able to measure these metabolites before and after in these people, before and after taking these supplements. And we actually see that there's an improvement in the blood that we can measure in the blood. So taking a step back, what we're offering to our potential customers is three things. Basically, a platform that can track your cognition, a blood collection sample where you can track the increase of the metabolites in your blood, and also the stool kit where you can track the increase of the probiotics in the stool. And obviously we've done more than just making them. We actually went to the market, spoke to potential customers, and these are our new hires. Both of them from Oxford. One of them is here, Laura. but they are here to really make sure of the reality that we're actually making a good contribution to the society to actually try to cure or to treat Alzheimer's disease. And just a few words about our story. So back in the days, we did lots of sort of science or innovation. And 2 years ago, we've established a lab at the Milner Center, and then we've manufactured. Thank you. And then more and more, we're starting to do our clinical research, and then also to develop this this customer platform or this service that we're offering to potential customers. And what we want to do with another £2 million is actually we want to basically build our B2B network, which is basically we've been talking to care homes, we've been talking to doctors who can recommend us, both here in the UK and also abroad. So basically we want to be market ready to help as many people as possible, and in doing so we want to make sure that we can actually help them by doing this service to help track these neuroprotective metabolites. So this is the team. Before it was just basically myself, but now we have Jake and Laura who just joined to really deliver on the marketing side. And with that, I just have one last question. Would you guys like, or would you like to join us in developing this safe, effective, and affordable method as a treatment for Alzheimer's disease? Thank you very much. And just to show that it's safe, I'm gonna take one of the probiotics, okay?
One quick question. John.
Are you still staying down the probiotics route and trying to get just better measures of efficacy? And how are you going to do that? Or are you going to go further into sort of medical?
So we want to we want to do both. Basically, our current short-term plan is obviously we want to do more of this research, of this service, but then our 5-year plan is really to do like larger scale trial and work with regulatory agencies to allow people to actually prescribe it. So in the ideal world, right, maybe in 5 to 10 years, we see a world where you can basically, if you don't have Alzheimer's, but you're worried or you have a family history, then you can go over the counter and buy it and buy the probiotics as a supplement. And also, but if you have, unfortunately, a diagnosis of Alzheimer's, then the doctors can actually prescribe or recommend it.
Right, so up next, we have Savas from Pinepeak.
Hi, I'm Savas, co-founder and CEO of Pinepeak. I have a PhD in combustion science, and my job is to predict wildfires. Several years ago, my family's home was destroyed in a wildfire. And just 2 blocks away, my PhD supervisor's house survived untouched. That made no sense. And it led me to ask one question. Can we predict this before it happens? And as it turns out, this is not only my question. It is the same question insurers and disaster modelers ask worldwide. Wildfires are increasingly frequent and severe due to climate change. And as a result, wildfire is not just a forest issue, it is a home issue with massive socioeconomic consequences. In the US alone, over $2 trillion worth of property is at high risk of wildfire damage because it sits right where vegetation meets human infrastructure. And as we heard before, insurers are pulling out of entire regions and zip codes and neighborhoods simply because the risk is poorly understood. At Pinepeak, we exist to make this risk predictable. We have built a powerful wildfire simulator inspired by jet engine research at the University of Cambridge, and we have coupled that with Earth observation data and geospatial AI to create a digital twin of the flammable landscape that is fast and accurate enough to predict wildfire spread in any terrain and be operational. So using this capability, we are able to predict fire in any terrain across wildland and built environment down to the individual house, and also do risk assessments accounting for millions of scenarios. Here is an example of a case study from the Palisades fire last year. In blue, you can see the footprint of the fire as observed by satellite 8 hours after ignition. And overlay to that, you can see our simulation of fire spread. And I have to say that the timing and the rate of spread prediction that we have is completely unprecedented and the best it can be. But on top of that, we also capture super fine grain details of how and why damage occurred that day. And this is a superpower we have that nobody else has. So using this, we are actually developing 2 main product lines and 2 value propositions. One is risk management, giving insurers and asset owners the ability to understand, price, and mitigate wildfire risk. And second, disaster response, giving to any stakeholder affected by wildfire the ability to have near real-time data feeds to support faster and better informed decision making. And we are doing exactly that by building our software platform we call FlameSight, and that we can provide to customers in many shapes and forms. Okay, so this is the most important slide for today. This is our traction. So last year when I pitched, I didn't win, but I was thankfully a finalist and given the opportunity. But then we were just starting. Pinepeak was an idea, going live after having raised some money. And we have used that to create real traction. So we have contracts in place with multi-year licenses. We have revenue share agreements with partners from Lloyd's. We have scheduled and started pilots and proof of concept projects with insurers, reinsurance brokers, and utility companies. We recently graduated from Lloyd's Lab, the world's leading insurtech accelerator, and we also won an award from Lloyd's of London that is also considering and investing in Pinepeak. We are also participating in the 11 million X Prize wildfire competition that is being, we are a top 6 finalist team, and this competition is taking place in 10 weeks, and our objective is clear: detect and simulate fire very, very quickly. We have also done other things. But the most important accomplishment is that we grew the team massively. We have an exceptional team of people that work at the cutting edge of multiple disciplines, from computational modeling and statistical sciences to computer vision and remote sensing. Talking about all this progress actually helped us create revenue. We actually have real revenue. And we also have a big pipeline of customers and projects. So we are projecting to have a revenue of about $500,000 by end of this year. This will become hopefully $2 million after that, just with the existing pipeline. And if things go well and we expand the pipeline further and we roll out the products as we plan, we have the potential to reach 20 million within 5 years. That is not only from insurance, but also other sectors like in the utility space and emergency response. Now, why coming here and pitch to you for the Angel Prize? Well, because every penny counts. So we raised some money already. We have raised £450,000 so far in convertible notes, but we are actually operating very, very lean, and our runway ends this summer. Now, we have a lot of projects and we have a lot of compute. We are using Google Cloud computing credits, but these are running out. So actually, if we win the prize money, we're going to upgrade our GPUs in a cluster that we have built to run more computations. Well, because money runs out, we are actually also happy to say that we just opened an equity round. We are looking for £1.5 million of investment to basically convert all this customer pipeline into the annual recurring revenue that we deserve. And with that, I want to say thank you. We are Pinepeak. We make wildfires predictable, and we're just getting started.
I have just a quick question. Being a standalone company rather than going as part of another company at something to sort of grow a bit faster, have you considered?
Well, scaling via platforms, or this is what you're thinking? Yes, actually, we're doing it already. So one of the agreements that we have is revenue share, is basically partnering with a climate risk insurance platform that is regulated by Lloyd's, and that basically enables us to give them our modeling capability and then taking revenue share out of the gross written premium.
Exactly.
Yeah.
Thank you.
Thank you so much, Sebastian. Right, and to conclude this marathon of pitches and these all very, very impressive, really, presentations we have seen today, I would like to invite Omid up from Remedium Energy.
Good evening, everyone. My name is Omid. I'm co-founder and CEO of Remedium. But today I want to tell you a story. Yes, I'm one of those guys. So come back with me to January of 2020. I was in my third year of PhD. One day in the lab, I saw a new face, a visiting scholar from Canada. His name was Moji, and I was given a task to show him around Cambridge. So we headed out. I remember it was a sunny day. I know, sunny January, UK, sounds suspicious already. But believe me, it was sunny. We ended up at the cafe in front of King's College, talking, like all good PhD students, about our research. Because let's face it, as a PhD student, we didn't have anything else going on in our life. Moji's PhD was on developing a new material for carbon capture. I was always skeptical of carbon capture. So I asked, Moji, why do we need carbon capture when we have renewable energy? Moji wrote down these 3 numbers. He explained that 20% of all CO2 emission comes from industries with inherent CO2 emissions. These emissions can only be eliminated with carbon capture. He continued that point source carbon capture is currently too expensive, $100 per ton. And 60% of that cost is associated with two things, material and energy. Then he showed me his material, lime loop, that can capture 36 times more CO2 over its lifetime than natural limestone, which cuts the material cost by more than 80%. But still didn't know how to reduce the energy cost. I told him, Moji, I might have a solution for you. I explained that my PhD is on heat batteries, which convert cheap electricity into heat, store it, and later on convert it back into electricity. Moji looked more confused. Fine, how does that help me? My answer, 4 words: carbon capture heat battery. I explained that when we expose lime loop to exhaust gases, it captures CO2 and releases high temperature heat, which we convert into electricity. Later on, we convert cheap electricity into heat to regenerate lime loop, so it can capture CO2 again. Since the electricity we buy is cheaper than the electricity we sell using electricity arbitrage, we're not just reducing the energy cost, we are making money from it. This idea excited both of us and led to founding Remedium. And it all started on that sunny day. Since last year that I started working full-time on the company, we have shown by taking actual 2024 spot electricity and natural gas prices that our cost of capture is only $13 across Europe. We have tested lime loop for 100 cycle reaching TR5, built a demo of our carbon capture heat battery reaching TR4, filed 2 patents, participated in several accelerator programs across Europe, US, and UK, won international awards and grants equivalent to £300,000, and received 2 letters of intent from 2 big cement manufacturers. And beyond just the low cost, we produce food-grade CO2, sold at $200 per ton, and our process is waste-free, because lime loop is converted into cement after its lifetime. Our long-term goal is to build carbon capture plants for our clients through joint venture partnership with engineering firm. And to get there, we have 2 key milestones: manufacture lime loop at ton scale and build our own MVP. In short term, we sell lime loop directly to companies that are currently using natural limestone for CO2 capture. And in medium term, our MVP can be sold as a modular carbon capture heat battery for industrial heat decarbonization. This phase approach enables us to generate early revenue while advancing our 2 aspects of our solution, de-risking our path to full-scale carbon capture market. Another thing that we have achieved over the last year is our team. Our team is much bigger. We have PhDs, postdoc, MBAs from some of the top universities around the world, and more than 100 years of accumulated experience in relevant research, industry, and startups. And we are currently raising £1.5 million pre-seed round to do 3 main things: manufacture lime loop at ton scale, do a live flue gas test of lime loop reaching TRL8, and demonstrate the whole solution carbon capture heat battery at kilowatt hour. By the way, here's a photo of me and Moji on that day. You see, I told you it was sunny. So now tell me, what do you do on a sunny day in January? You step outside so you don't miss it, right? Same applies here. If you're interested, please reach out. Thank you.
Tell us a little bit more about the commercialization process. Sure. What's the sort of first big step you're going to take?
So I think one of the challenges with what we're developing is that the final product costs, for example, $200 million. So that's not an investable approach to go. What we have done, we have identified the certain type of companies, especially in direct air capture, that are using natural limestone for CO2 capture. We have talked with a couple of them, and they are interested to replace basically the natural limestone with our material because it's reduced its energy costs, basically. And so that's the phase 1. That's why we're focusing on the lime loop production, scale up, and production initially. And in medium term, we're looking at containerizing basically our solution first and building a small scale, basically 20-foot container can provide 11 megawatt hour of heat storage and 5 kiloton of CO2 capture only to industries to gradually they reduce it. And it costs only $500,000 compared to 200 million. So we're kind of looking at this phase approach out of basically conversation we had with customers, especially in EU because of the ETS situation, that the allowance is going down, but it's still quite high yet. So they don't need to fully decarbonize the solution yet. So that's how we're kind of approaching the commercial challenges that such a solution might have.
Thanks. And can you just say a little bit about what the material looks like when it's captured more?
It's literally
CO2. Does it, they look exactly
it
the
looks
same? Or
exactly the same. It just heats up. No.
Yeah,
it's like it will be denser. Obviously, it's the porosity fills out, but it doesn't look different. Yeah.
Right. Okay. Thanks.
Okay. Thank you very much, Amin. Right, just a quick round of thank yous again to all our 15 presenters and 14 presentations. Amazing things that we have seen. Fantastic questions, and to our judges, and thank you to our judges, and thank you to everyone in the audience for staying for this marathon of high level and high quality presentations. Now, I would like to invite the audience to venture outside into the atrium for some networking and drinks while the judges deliberate, and this is not going to be an easy task. So please make yourself a way to the atrium. Thank you.
We have considered, we've deliberated, we've argued, and the winner of the Bradfield Prize this evening, there's one prize of £10,000, is GreenMixes. So congratulations. So, please come forward. Congratulations.
Thank you so much.
I think we need to get something with all of us together. All right, it's together. Thank you. Right. There we go.